May 2011, M1, question 6. Part 1, draw a diagram. We will have the weight of the crate acting down, so that is 30G. The reaction to the plane. There is coefficient of friction, and we have a rough plane, and the crate is the point of moving up the plane, so friction will oppose motion and is moving down the plane. I'm going to add the angles to my diagram. So 60 degrees for the slope, and because of my Z angles, I know that P is at 60 degrees to the slope as well. I'm going to quickly redraw the diagram now, showing all the components. R and friction are already perpendicular. The weight will have cos 60 acting into the plane and sine 60 acting down the plane. P is moving into the plane and down, so it will have a component up the plane and a component into the plane. So we have P cos 60 acting up the plane and P sine 60 acting into the plane. Using equilibrium, R has to equal 30G cos 60 plus P sine 60, and friction plus 30G sine 60 has to equal P cos 60. Going to use friction equals mu R, and we're told in the question that mu is 1/3, and substitute in my two equations. Friction is P cos 60 minus 30G sine 60 equals 1/3 30G cos 60 plus P sine 60. Now becomes a pure maths question where we have to expand and collect common terms. Cos 60 is a half, so we have a half P minus sine 60 is root 3 over 2 equals 1/3. 30G cos 60 is 15G plus root 3 over 2P. On the left hand side I have a half P. I'm going to bring over the P from the right hand side, so that is going to be minus 1/3 times root 3 over 2P has to equal 5G plus 15G root 3. And manipulating that in the calculator, we get that P is 1436, which to three significant figures is 1440 newtons.